Intelligence, a concept we often grapple with, takes on myriad forms across scales, from the intricate dance of molecules to the complex problem-solving abilities of humans. Intelligence manifests in diverse ways. This fractal nature of intelligence suggests that it is not confined to a single definition or scale. Instead, it emerges as a spectrum, a continuum of cognitive abilities that permeate the fabric of our universe. Consider the collective intelligence of ant colonies. While individual ants may exhibit limited cognitive abilities, their collective behavior demonstrates a remarkable capacity for problem-solving, adaptation, and self-organization. Similarly, the intricate workings of the human brain, with its billions of interconnected neurons, give rise to our unique cognitive abilities. These examples highlight the fractal nature of intelligence. It's a phenomenon that transcends scales, manifesting in different forms and complexities. Understanding this principle is crucial as we explore the future of artificial general intelligence, or AGI. The pursuit of AGI is not a quest for a singular technological breakthrough, but rather a journey along a complex and multifaceted spectrum. AGI, in its truest sense, represents a level of artificial intelligence that can perform any intellectual task that a human being can. However, this definition belies the diverse range of cognitive abilities that could emerge along this spectrum. We must move beyond the binary notion of human-level AGI and embrace the possibility of a more nuanced understanding. The development of AGI will likely involve the emergence of systems with varying levels of competence across different domains. Some systems may excel in specific areas, such as language processing or scientific reasoning, while others may exhibit more general-purpose cognitive abilities. While current AI systems have achieved remarkable progress in specific domains, they're still far from exhibiting the general-purpose intelligence characteristic of AGI. Today's AI relies heavily on classical computation, which excels in tasks involving pattern recognition, data analysis, and optimization. However, these systems struggle with tasks that require common-sense reasoning, adaptability to novel situations, and genuine understanding of the world. The limitations of current AI stem from their reliance on rigid algorithms and vast amounts of labeled data. These systems lack the flexibility and creativity that characterize human intelligence. To achieve AGI, we need to explore alternative computational paradigms that can overcome these limitations. Multidimensional cognition navigating complexity. The world we inhabit is a complex, interconnected web of systems. To navigate this intricate landscape effectively, AGI systems will require multidimensional cognition, the ability to reason, learn, and adapt across multiple levels of abstraction. This includes understanding complex relationships, integrating information from diverse sources, and making decisions under uncertainty. Multidimensional cognition will be crucial for AGI systems to interact with the real world, collaborate effectively with humans, and contribute to solving complex global challenges. Achieving this level of cognitive sophistication will require not only advances in computational power, but also a deep understanding of the principles underlying human cognition. The future of intelligence, a tapestry of possibilities. The pursuit of AGI is not merely a technological endeavor, it is a journey of exploration that will redefine our understanding of intelligence itself. As we delve deeper into the realm of artificial intelligence, we are likely to encounter new forms of cognition, emergent properties, and unexpected possibilities. Quantum computing, with its potential to revolutionize information processing, could unlock new frontiers in AGI development. By harnessing the principles of quantum mechanics, we may be able to create AI systems that can tackle problems currently intractable for classical computers. The integration of biological and artificial systems could lead to the emergence of hybrid intelligences that combine the strengths of both domains.